In this video, I'm going to talk about how you understand and analyze position time graphs. Graphs give you a picture of how an object is moving, and in position time graphs, that picture tells you how the object's distance from the starting point or position in time, position in space, is changing over time. So the two axes, the x-axis will be time, across the bottom, the horizontal one, and the distance or the position of the object will be our y-axis or our vertical axis. The actual starting point is traditionally given as the 0 line, so the object is going to start, or that's sort of their original position if we're taking the graph kind of partway through, say if we were looking at a graph only of this section here. So the 0 line is that starting point, and then the shape of the line, or really in particular the slope of the line, tells you what is happening then with the motion, whether it is speeding up, slowing down, not moving at all, accelerating and changing over time, or staying constant. So let's first look at constant versus changing velocity, or a constant or changing speed, because we're really just thinking about moving objects in a straight line at this point. And so direction is not really terribly involved. If an object is moving rightward or in a positive direction, and it has a constant velocity, it never changes. You're from this instant moment, you're traveling, say, in a car at 60 miles an hour, and you stay at that speed or at that velocity. The position time graph is going to show a straight line with a positive slope, like we have down here in this illustration. Straight line going upward to the right, so we know that this object is moving in a rightward or a positive direction, and its speed or its velocity is not changing. So say after 1 second, it has gone this far, and then after another 1 second, it has traveled this far, and after another 1 second, it has traveled that far. If an object, also moving rightward or in a positive direction, is changing its velocity, if it is accelerating, and in this case we're only thinking about things that are accelerating, speeding up or slowing down, not sort of changing speeds in the middle, but that can be put on a graph. But if we're looking at just sort of a one-way acceleration, then your position time graph will show a curved line. So this is the illustration given on the right, where the line has sort of a flattened appearance. It kind of, if you think about, if instead of a straight line, it sort of dips down like it's a convex line. So a curved line tells you acceleration is happening, or changing in velocity is happening in a position time graph. Sort of the key thing to remember when interpreting position time graph is that how the slope relates to the velocity. So basically, the greater the slope, the faster the motion of the object. So velocity increases with an increased slope. And slope, of course, in a straight line is going to refer to how steep a line is, whether you're going like up a steep hill or down a steep hill. But in a curved line, I'll show you how to figure that out in a minute. So as already said, positive slopes are seen by motion to the right from the 0 corner, and negative slopes would be seen by moving to the left. So looking at these 4 lines that are given here on this illustrated graph, line A, you can see, is a negative slope. It is moving downward off to, at the 0 point, the object would be up here, and then it is traveling. As it travels in time, it is moving actually back towards your starting point, with 0 being your starting point. So it's going in a negative direction or a leftward direction, and it is fairly steep. So we would say this was, going pretty fast, and it's going in a negative direction. Both lines B and D are going in a positive direction because we have a rightward line, a line going off to the right from the 0 point. But they have 2 different slopes. So the flatter slope is moving more slowly than the steeper slope between these 2 lines. And then line C is just a horizontal line. And we know that this represents a constant speed if we're talking about speed. But in position time graphs, we're talking about how far something is moving from a starting point. And this object, because it's not, the position part is not changing, this is the same position, shown by this by this straight line. So the same, let me spell this all out, the same position. And so it is not moving. It is stopped. It is at rest. Sometimes we say it's stationary. Those are all words that mean that it is not moving. So time is still passing. So the object was here at 1 second. It's still here at another second. It's staying at the same spot. So it is not moving. It is at rest. It is stationary. That's what a horizontal line means in a position time graph. So looking at curved lines, it's a little bit trickier to identify what's happening with the slope. There is slope, but it changes as the line curves, and you basically are looking at an instantaneous slope at any particular point on that curved line. Overall, negative slope is still going to indicate a negative velocity, generally, returning to a starting position. And then the curve itself shows how the velocity is changing. So the way to figure out a slope on a curved line is to think what a straight line that just touches at one single dot would look like. So it's kind of like balancing a pencil on the end of your finger. If the curved line is your finger and this is the dot where the pencil touches your finger, then the straight line is that pencil sitting on top, and the straight line is the curve at that dot. So if we compare the curve here at the dot B compared to what happens with the slope of the curve here on dot F, imagining resting a pencil there on that particular dot, you can see that this line for B is much flatter. It does not have as much of a slope as this line for F. And so this is telling that over time, the acceleration is causing a speeding up because the velocity is faster at point F. The line is steeper than at point B. So then to just kind of put it to comparison, we have two leftward moving objects here. They are both moving in a negative direction, but on the left, this particular graph is showing an object that is speeding up because for any particular dot, as we draw sort of a straight line that would balance on that curve at that point, as compared to balancing on the curve at this point, the slope of those two lines is showing that this one is flatter, so it's moving more slowly at that first dot, it's moving faster at the second dot. And so overall, this object is speeding up. Both acceleration and motion both happening in the same direction, in this case would be negative. Looking the other way, we have a line that's curving kind of in the opposite direction, but again, we use the same technique. We just have to put our slopes on the other side of the line. So we have our first dot up here, and our slope would be this way, and then our second dot down here. We put our slope, balancing a straight line, and we compare these two slopes, and you can see that it's becoming a less of a slope, a more horizontal-ish line as we move in time. And so this is an object that is slowing down. Again, it is moving in a negative velocity. That means that the acceleration is going to be in the opposite direction because slowing down is caused by opposite directions of motion, velocity, and acceleration. So velocity to the left, acceleration to the right on this second graph. So if you're looking at all sorts of curves, some of these are labeled on this particular diagram, but A is representing our starting point, and that position is always being compared to that point. We have a positive slope here. B is moving positively and very fast. It has a very steep slope. We have a continuous motion moving off for line C. It is going in a positive and a fairly steady, fast pace. Then it's not moving for a certain amount of time. And you can use the graph to figure out the exact amount of time. You can also use it to figure out the exact velocity. Because you can do a distance over time calculation. So, in here, let's say each of these are a second. So we'd say it was stationary for 1, 2, 3, 4 seconds. And then at this point, it starts returning to the starting position. So we have a negative slope, but again, fairly fast. And then finally, our curved line is moving in a positive direction. And if we just compare our slopes from the beginning to the end, here's fairly horizontal one. Here we have a fairly vertical one. And so the object is getting faster as it goes over time. So that gives you the overview of the key points of interpreting position time graphs. So just check your understanding. Can you name which axis on a position time graph is for position or distance, and which one is for time? Can you identify if the velocity is constant or it's changing based on the shape of the line? Is the line straight? Is the line curved? Can you use the slope of the line to determine if the velocity is rightward or positive direction or leftward in a negative direction? And then finally, can you use the slope of the line to determine if an object with changing velocity is speeding up or slowing down? So again, if you have any confusion about any of these points, go back and take a second look at the video.